to True Projects. In this video, we are going to explain about a project titled Fraud Detection and Banking Data by Machine Learning Techniques. This project delves into escalating the concern of deceptive transactions within the realm of online banking, coupled with the intricate landscape of fraud detection, emphasizing the criticality of the SIFT fraud detection post-occurrence to avert the potential cascades of deceit. This discourse elucidates the multifaceted nature of fraud, encompassing the wrongful manipulation for the personal or the financial gain. Specifically, the credit card fraud involving the illicit deployment of the credit card details for the digital or the physical purchase is highlighted. The narrative delineates the dual strategy of the fraud prevention and the detection as a potential against the potential losses stemming from the fraudulent activities. Moreover, it accentuates the technology's pivotal role in fortifying the fight against the fraud, with the researchers relentlessly exploring the novel approaches and refining the existing methodology to bolster the efficacy and the resilience and this ongoing battle against the financial deceit. In this study, we introduce an advanced model for detecting the fraudulent banking transaction leveraging the prowess of the machine learning technique. Our primary objective revolves around enhancing the efficacy of the light GBM approach, encompassing the strategic utilization of the class weight tuning hyperparameters alongside the integration of CADBoost, XGBoost, and the deep learning paradigms, all meticulously calibrated for the hyperparameter optimization. Real-world transactional data serve as a proving ground for our proposed methodology, evaluated through the lens of recall precision metrics and subjected to the rigorous assessment employing a five-fold cross-validation strategy. Our mission centers on achieving the exceptional level of precision recall (FNSCO) and affording the ability to accurately discern the fraudulent activities, all while addressing the inherent challenges posed by the unbalanced data distributions. Additionally, we delve into the selection of vital features through the information gain method, effectively streamlining the training data dimensions through the judicious attribute selection. By amalgamating the cutting-edge techniques and tailored feature curation, our model aspires to forge the new frontiers in the fraud detection within the dynamic landscape of the banking transactions. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7, Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. Here we need to import the essential Python libraries, modules, and the frameworks encompassing the data manipulation and processing, visualization, and the model construction functionalities. And the second one is exploring the dataset. A meticulous exploration of the banking dataset is undertaken to comprehend its structure, attributes, and the potential challenge. And the third one is data processing. Data processing procedures are implemented to cleanse, normalize, and transform the dataset, optimizing it for subsequent analysis and the model development. And the next step is visualization using the Seaborn and the Matplotlib. These libraries are harnessed to create the insightful visualization of the dataset, unraveling the pattern distribution and the potential correlation within the data. And the next step is label processing. It is executed to ensure the compatibility of the target variable with the chosen machine learning algorithm. It's crucial for the supervised learning tasks like of classification. And the next step is feature selection algorithm is applied to identify and retain the most influential attributes from the dataset, enhancing the model efficiency and the interpretability. And the next one is split the training and the testing data. The dataset is divided into the distant training and testing subset. The training data facilitate the model training, while the testing data remains untouched until the evaluation stage. And the next step is building the model. Here, various machine learning models are built for the fraud detection and the banking data. The first one is logistic regression. It is a fundamental classification technique implemented to predict the probability of fraud occurrence based on the attribute from the banking data. It models the log odds of the response variable and facilitates the binary classification of the transactions. And the second one is LGPM. It stands for Light Gradient Boosting Mission, is a fine-tuned to accentuate the fraud detection capability, and its efficient gradient boosting methodology enhance the model accuracy by iteratively improving the weak learners, ultimately leading to a robust ensemble predictor. And the next one is XGBoost. Extreme gradient boosting is another prominent boosting algorithm aimed to excel in fraud identification. Its gradient boosting approach emphasizes both the accuracy and the computational efficiency, contributing to the accurate prediction of the fraudulent activity. And the next step is CATBoost. CATBoost is leveraged to enhance the fraud detection accuracy by addressing the categorical variable. Its integrated categorical encoding and the decision tree ensemble architecture make it particularly adept at handling the banking data intricacies. And the next one is voting classifier. Here it uses the prediction from logistic regression, XGBoost and CATBoost. By capitalizing on the diverse algorithm, this ensemble technique aims to enhance the overall prediction robustness. And the next one is voting classifier. It combines the prediction from the logistic regression and the XGBoost, blending the linear and the gradient boosting approach to yield a balanced ensemble model for the fraud detection. And the next one is voting classifier. It combines the prediction of the XGBoost and the CATBoost are merged within this. By integrating two boosting techniques, this ensemble seeks to capture a wide array of fraud patterns. And the next one is voting classifier with LG plus CAT. Here, its fusion of logistic regression and the CATBoost prediction characterize this voting classifier. The amalgamation of the linear model with the categorical variable focused algorithm aims to enhance the ensemble diversity. And the next one is ANN MLP. It specifically the multi-layer perceptron architecture explores the complex relationship within the banking data. Its layered structure allows for intricate pattern recognition, contributed to the nuanced fraud detection. And the next one is decision tree. It's a partition data based on attribute values leading to the hierarchical decision-making process, and the fraud detection decision tree delineates the features indicative of the fraudulent transaction. And the next one is stacking classifier. It combines the prediction from the various models leveraging the collective intelligence to make a final decision. It aims to snatch the individual model strength for improved fraud detection. And the next one is random forest. It's an ensemble of decision tree is designed to combat the fraud by aggregating the diverse tree-based prediction. It excels in capturing the complex pattern and the anomaly within the banking data. And the next one is user gives the input. A user-friendly interface developed with Flask employs the user to the input relevant banking data for the fraud detection. And the next step is the given input is pre-processed for prediction. User provided data undergoes the pre-processing encompassing the feature extraction, normalization, and formatting to align with the model requirements. And the next step is trained model is used for the prediction. The trained model analyzes the pre-processed input to predict the likelihood of fraud, capitalizing on identified pattern and the attribute. And the last one is displaying the final outcome. The model prediction outcome is showcased to the user via the Flask interface, conveying the potential presence of fraudulent activity and contributing to the informed decision making and the financial security. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, and the static folder containing of the folders like CSS, JavaScript, images, and uploads and web fonts within it. And the template folder containing of the HTML documents typically include about, form, index, notebook, result, sign-in, and sign-up pages within it. And the app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model file contains the information of the algorithm and loaded into the project code during the runtime to utilize the trainer model for the various tasks, such as making the prediction on the new data, performing the specific operation. And the signup.db is an file appear to be the database file used to store the user information, and the test case document containing of the various test cases that will be used to test the performance of the model. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues within it. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we can see the title and some information about it, and then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of username and password and those details that are need to be filled. And then click on the sign in button. Here it will redirect to the sign in page containing of some input details that are need to be filled within it. I'm entering those details. As of time 7, and the V1 is minus 0.644 and V2 is 1.417 and the V3 is 1.074 and the V4 is minus 0.4921 and the V5 is 0.9489 and the V6 is 0.4281 and the V7 is 1.1206 and the V8 is minus 3.807 and the V9 is 0.6153 and the V10 is 1.249 and the V11 is minus 0.619 and the V12 is 0.2914 and the V13 is 1.757 and the V14 is minus 1.3238. V15 is 0.6861 and the V16 is minus 0.0761 and the V17 is minus 1.2221 and the V18 is minus 0.358 and the V19 is 0.324 and the V20 is minus 0.156 and the V21 is (1.94) and the V22 is minus 1.0154, and the V23 is 0.0575, and the V24 is minus 0.6497, and the V25 is minus 0.415, and the V26 is minus 0.051, and the V27 is minus 1.26206, and the V28 is minus 1.0853, and then click on the amount is of 40.8, and then click on the submit button. Here it predicted and the given as the transaction is non-fraud of 0.0%, and by clicking on the home button here we can re-enter the other details too. I am entering those details as of time 7519, and the V1 is of 1.2342, and the V2 is of 3.019, and the V3 of minus 4.304, and the V4 of 4.732, and the V5 of 3.62, and the V6 of minus 1.357, and the V7 of 1.7134, and the V8 of minus 0.4496, and the V9 of minus 1.282, and the V10 of minus 2.447, and the V11 of 2.101, and the V12 of minus 4.609, and the V13 of 1.464, and the V14 of minus 6.079, and the V15 of minus 0.339, and the V16 of 2.581, and the V17 of 6.7393, and the V18 of 3.642, and the V19 of minus 2.721, and V20 of 0.0090, and the V21 of minus 0.379, and the V22 of minus 0.704, and the V23 of minus 0.656, and the V24 of minus 1.632, and the V25 of 1.4889, and the V26 of 0.5667, and the V27 of minus 0.0100, and the V28 of 0.1467, and the amount is of 1, and then click on the submit button. Here it predicted the transaction is fraud and the probability of the fraud is 0.76%. And in conclusion, we state that the proposed machine learning approach using the LightGBM, CatGhost, XGBoost, and the deep learning technique significantly improve the performance of fraud detection and the real unbalanced data set. The proposed method are evaluated using the recall precision metric and achieve the high level of fraud accuracy precision recall FN score. We also discussed the importance of using the hyperparameters to address the data imbalance compared to the sampling method, which lead to the better results and reduces memory and the time needed to evaluate the algorithms.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.